Hello, my darlings. Okay, so here we are with the quotient rule. Now, the quotient rule is used when we have something like the function f divided by the function g, and we want to take the derivative with respect to x, or the derivative with respect to x of f of x divided by g of x. In either case, the derivative is the derivative of f of x times g of x minus f of x times g prime of x all over the denominator g of x squared. Now you should notice that the top is very similar to the product rule, except it's subtraction. And then you have this denominator. So we keep the old denominator, but we square it, okay? You can memorize it that way. There is another way to memorize it. This one is low d high minus high d low all over low squared. So high means the numerator, low means the denominator. The d means take the derivative. Now, yes, in our formula, we have this first part in the other order. We have d high times low, right? This is the derivative of the top times the low, the denominator. But there is a song that goes with this second one, which I will play for you in school. That might make it easier for some of you to remember. Okay, so let's put this derivative rule in words. So the derivative of the quotient is the derivative of the top function times the bottom function. You keep the bottom. Minus the top function, so this time you're keeping the top, times the derivative of the bottom function, all divided by the bottom function squared. So let's take a look at the quotient rule in action. So here we have f of x is 2x cubed minus 3x squared minus 4 all over x cubed. And if we use this rule, the low d high minus high d low over low squared, the low is our denominator, x cubed, times, now we need the derivative of the top. So the derivative of 2x cubed is 6x squared minus the derivative of 3x squared is 6x minus the derivative of 4 is 0, so we don't need that. Then we're going to have minus, because the rule is for minus, we're going to keep the top, 2x cubed minus 3x squared minus 4 times the derivative of the bottom part, which is 3x squared. And I just moved it to the front so that it's easier for me to remember to distribute not only the 3x squared, but that negative sign, that this negative 3x squared is going to have to distribute. Okay, that's why I put it in front. Over the bottom x cubed being squared. Okay, so now we've got some algebra to do, your favorite. So x cubed times 6x squared is 6x to the fifth, and x cubed times a negative 6x is negative 6x to the fourth. Then we're going to distribute that negative 3x squared. So negative 3x squared times 2x cubed is negative 6x to the fifth. Negative 3x squared times a negative 3x squared is a positive 9x to the fourth. And negative 3x squared times negative 4 is a positive 12x squared. And this is all over. Now, because that denominator is a monomial, we're actually going to square it. X cubed times x cubed is x to the sixth. Okay, now, what happens in our numerator here? Let's see what we can do. The 6x to the fifths are going to add to 0. Negative 6x to the fourth plus 9x to the fourth, that's going to give us 3x to the fourth. And we still have a plus 12x squared all over x to the sixth. We are not done, my dears, because there is a greatest common factor in the top. The only one that has to be factored out is the x squared. You can leave it 3x squared plus 12 if you want, because the only thing I can simplify with the denominator is that x squared and the x to the sixth. If I was to simplify that, right, the x squared is going to take 2 away from here and make that x to the fourth. So we would have 3x squared plus 12 over x to the fourth. But Technically, back here, when we were taking out the greatest common factor is 3x squared, isn't it? Which would leave us with an x squared plus 4 over x to the 6th. Then you can simplify, but your 3 is still going to be there, and you're going to have 3 times x squared plus 4 all over x to the 4th. I will accept either answer is perfectly fine with me. Okay? Let's try another example. Now the next couple are actually going to be easier than the first one we did. The first one had more algebra than this one will, so you'll be okay. All right, so we have f of x is x plus 4 over x minus 4. So our derivative of f of x is called f prime of x. So we're going to do low, so we keep the x minus 4. D high, the derivative of x plus 4 is just 1. Minus high, so we keep the x plus 4, times the derivative of the bottom x minus 4 is 1, all over the bottom squared. Now if you look at the top, 1 times x minus 4 is just x minus 4. But this is a negative 1 you have to distribute, so you're going to have negative x minus 4. And do yourself a favor, do not square out the denominator. Right now, we are just finding the derivatives. Eventually, you're going to be using the derivatives for things. And when you use the derivatives, you're going to want them in factored form so that you can find out when the derivative is 0 and when the derivative is undefined, which means if you squared out the x minus 4, you would then have to factor it. So don't make more work for yourself. The only time you'll have to square out the bottom is if it's a monomial. Okay? So the next thing we're going to do, I'm just going to write my f prime of x here. We combine like terms. Notice the x minus x is going to add to 0. That's going to leave me in the top. A negative 4 minus 4 is negative 8 over the quantity x minus 4 squared. And we are all done. Here's another one. Now at this point, if you think you've got the quotient rule, feel free, stop the video, do the guided practice problem. You can do one at a time or do them all and come back. It's up to you. Do one, fast forward, check if your answer is correct. If your answer is correct, great, go on to the next one. Otherwise, rewind a little bit, see where your mistake was, okay? It's up to you how you make this video work for you at this point, okay? So here's the next one. F of x is 3x plus 1 over 5x plus 2. So the name of our derivative is f prime of x. We're going to take the derivative of the top, which is 3, times keep the bottom, 5x plus 2, minus keep the top, 3x plus 1, and the derivative of the bottom is 5, all over the bottom squared. Calculus is done. Now it's algebra. 3 times 5x plus 2 would be 15x plus 6. Then a negative 5 times 3x plus 1 is negative 15x minus 5, all over the quantity 5x plus 2 squared. Now in the numerator, the 15x's are going to add to 0, and all that's going to be left in our numerator, 6 minus 5 is 1, over 5x plus 2 quantity squared. And there you go. Now this next one's a little different because it's trig. Okay, so let's see what happens with the trig. The derivative of f of x is called f prime of x. So we do the derivative of the top. So the derivative of cosine is negative sine x times keep the bottom sine x minus keep the top cosine x times the derivative of the bottom sine x is cosine x all over the bottom squared. So now if we do this, negative sine x times sine x is negative sine squared x minus cosine x times cosine x is cosine squared x all over sine squared x. Now there is a greatest common factor here. It's a negative 1. And if you factor out that negative 1, you've got sine squared x plus cosine squared x all over sine squared x. Now, alarm bells should be ringing in your head because what is sine squared x plus cosine squared x? That's 1. which means our numerator, negative 1 times 1, is just negative 1 over sine squared x, and this answer is okay. Or some people like to go the extra step and say it's the negation of 1 over sine squared is cosecant squared x. Either answer is perfect. Here's the next one. G of x is x squared plus 5x plus 2 all over x plus 3. So the derivative of g of x is g prime of x equals, we take the derivative of the top. The derivative of x squared is 2x, plus the derivative of 5x is 5, plus the derivative of 2 is 0, so I'm done, times, keep the bottom, x plus 3, minus, now I'm going to keep the top, x squared plus 5x plus 2, times the derivative of x plus 3 is 1, and this is all over the bottom, x plus 3 quantity squared. Calculus is done. Now we're doing algebra. So we're going to do 2x times x is 2x squared. 2x times 3 is 6x. 5 times x is 5x. And 5 times 3 is 15. Now we're going to take this negative 1 and distribute. So negative 1 times x squared is negative x squared. Negative 1 times 5x is negative 5x. Negative 1 times 2 is a negative 2. And this is all over the quantity x plus 3 squared. Now if we look at this, the 5x's are going to add to 0. Okay. And I'm going to bring down my derivative name here. 2x squared minus x squared is 1x squared. I've got a 6x still left. And then a 15 minus 2 is 13 all over the denominator squared. Good job. Okay, last one, but it's going to have two parts. So we have y equals x squared minus 1 over x to the 4th plus 1. And we're going to find dy dx. Now dy dx, remember, is just the name of the derivative of y. So the derivative of y is called dy dx. And we're going to do the derivative of the top. So the derivative of x squared is 2x. Derivative of the minus 1 is 0. Times, keep the bottom, x to the 4th plus 1, minus, now we're going to keep the x squared minus 1, that's the top, times the derivative of the bottom is 4x to the 3rd, and this is all going to be over the bottom squared. Okay, calculus is done. Now we're doing algebra. 2x times x to the 4th is 2x to the 5th. 2x times 1 is 2x. Negative 4x to the 3rd times x squared is negative 4x to the 5th. Negative 4x cubed minus 1 is a positive 4x cubed. And this is all over the quantity x to the 4th plus 1 squared. Now, if we combine like terms, let's see here. We have 2x to the 5th minus 4x to the 5th. That's a negative 2x to the 5th. We only have the 4x cubes, and we only have 2x. And it's all going to be over x to the 4th plus 1 quantity squared. Now, technically, this is an answer for dy dx. But I also know where this problem is going. So I'm going to look at, can we factor anything out of the top? If we factor anything out of the top, we would have to take out the common, let's take out a negative 2 instead of a positive 2. We'll take out a negative 2x, and that will leave us with x to the 4th minus 2x squared minus 1 all over the denominator, x to the 4th plus 1 quantity squared. Okay, now, why was that important? Because in part B, they're going to ask us, at which point does our function y equals x squared minus 1 over x to the 4th plus 1 have a horizontal tangent? Now, when you think about horizontal lines, right? horizontal lines have slope that's 0. Now remember, the slope of the tangent is the derivative. So if the slope of the tangent line is supposed to be 0, that means that the derivative dy dx has to be equal to 0. And if the derivative, which is a fraction, is equal to 0, that means that the numerator of our derivative is going to have to be equal to 0. Okay, so if we know that dy dx is going to be equal to 0, we're going to set the numerator negative 2x times x to the 4th minus 2x squared minus 1 equal to 0. Okay, or if you had it in the other form, you'd have negative 2x to the 5th plus 4x cubed plus 2x equals 0. Either of those are fine. Now I can tell by looking that if I have this factor negative 2x, I know x equals 0 is a root. However, this trinomial does not factor, which means I need to go to my calculator. So go grab your graphing calculator and we'll find those last 2 points where we will have a horizontal tangent. Okay, so we're going to enter our numerator into the f1 of x line. So it's negative 2x. Do not forget to hit multiplication before you open parentheses. Then we have x raised to the 4th. Get out of your exponent. Minus 2x squared minus 1. Then arrow down. We're also going to put in the function y equals 0 and hit enter. Now we can go to Menu, Geometry, Points and Lines, Intersection Points. Click on the graph of our numerator, click on the x-axis, hit Escape. I'm going to move my points a little bit so you can see them better. Okay, now if we only want it to 2 digits after the decimal, that's fine. If you need more digits, remember you hover over it, you press Control Menu, Attributes, move it up, and if you need 3 digits, move it back down to 3. Okay, there we go. Okay, so my last 2 answers that we found on the calculator were positive and negative 1.55, and now we have the 3 points where our function will have horizontal tangent lines. That means they're going to have the maxes and mins. All right, so we have looked at the quotient rule. Remember, when you have a function on top of another function, low d high minus high d low over low squared. That's how you find your derivative, or derivative of the top times keep the bottom minus keep the top, derivative of the bottom over the bottom squared. Have a great day, guys. Bye.